Good morning students. Let us deal with very interesting part of physics, that is ultrasonics. And I am Dr. Aruna Marolkar, Assistant Professor of Department of Basic Science and Humanities from Marathwada Institute of Technology Aurangabad is going to help you in this course. After completion of this lesson, students should able to differentiate between audible wave, ultrasonic wave and infrasonic wave. State basic properties of ultrasonic wave. Recognize various applications of ultrasonic wave like in medical field, scientific field and industrial field. State different methods of production of ultrasonic waves. Sound. One can say that sound is something that travels in air and reaches to our ear. Yes, of course. Now let us see what do you mean by sound. Sound is a mechanical disturbance from a state of equilibrium that propagates through an elastic material medium. So sound is a vibration that propagates as a wave through a transmission medium such as gas, liquids or solids. Remember, sound needs a medium like solids, liquids or gases. Sound is produced in a material medium by a vibrating source. Let us see an example. If we pluck a string of guitar, it vibrates and this vibration gives us sound. So here this guitar is vibrating source of sound. Now this sound in the form of compression and rarefaction reaches to our ear as shown in figure. Just now we have seen that sound is produced in a material medium by a vibrating source, and sound is a vibration that propagates as a wave through a transmission medium. Now here is another vibrating source, tuning fork. This tuning fork vibration will give us sound. So let us play the video in which tuning fork acts as a vibrating source which will give us sound. Try to listen the sound of tuning fork. When the tuning fork is plucked or hammered using a source, it will give vibrations and this vibration gives us sound. Let us listen the sound of tuning fork. Remember, sound requires a medium. The material medium may be solids, liquids or gaseous. Sound waves can be classified into three different types, depending upon its frequency. The first type is audible sound. The sound waves having frequency 20 Hz to 20 kHz, it is called as audible frequency range. Human ear is sensitive to this audible frequency range. The second type is ultrasonic sound. The sound waves having frequency more than this audible range, means more than 20 kHz, it is called as ultrasonic sound. And the third type, sound waves having frequency below or less than audible sound, it is called as infrasonic sound. So depending upon its frequency, sound is classified into three different types. One is audible sound, sound waves between frequency 20 Hz to 20 kHz, audible sound. Just we have listened the sound from tuning fork and sound from guitar. It is in the audible range. Ultrasonic sound, more than or above audible range. And third, infrasonic sound, below audible range. So audible frequency range is from 20 Hz to 20 kHz. We human beings are sensitive to this range and therefore this is called as audible range. The sound from guitar, drum, string, tuning fork, just we have listened, human vocal cord, all the sound which we listen, which human ear is able to listen, it is in the range of audible frequency. The second type is ultrasonic sound. The sound waves having frequency more than audible range, means more than 20 kHz, is ultrasonic sound. We human beings are not able to listen this ultrasonic sound, but still there are some animals which are able to listen this ultrasonic sound, just like bats, cats, mice. They are able to listen this ultrasonic sound. And the third type, infrasonic sound. The sound waves having frequency less than 20 Hz. It is infrasonic sound. Human ear cannot hear this sound, but elephant, whales can hear this sound. So we have seen that sound waves is classified into three main types. One is audible frequency range. Human ear is sensitive to this specific range from 20 Hz to 20 kHz, and hence in this diagram two human beings are shown near audible frequency range. The second one we have seen ultrasonic sound. The sound waves having frequency more than 20 kHz. Human beings are not able to listen this sound, but bat is shown. This bat is sensitive to this frequency range, and hence here in this picture bat is shown near ultrasonic sound. And the third one, infrasonic sound. The sound waves having frequency less than or below audible range is infrasonic sound. Human beings are not able to listen this infrasonic sound, but elephant is shown. Elephant and whales are sensitive to this infrasonic sound. The word ultrasonic is originated by a Latin word ultra. Ultra means beyond, more than. The word ultra means beyond, and the word sonic means sound. So ultrasonic means beyond sonic, means beyond audible range. So naturally what its definition becomes? The sound waves having frequency more than audible range, it is ultrasonic by its name itself. These ultrasonic waves are very special, and why they are special? Because of their properties. Their properties are different by this audible sound. So what are those properties? The first one, they are highly energetic, means ultrasonic sound contains energy in it. Just like ordinary sound waves, it can be reflected, it can be refracted, it can be absorbed. Their speed of propagation depends upon their frequency. Means the speed of ultrasonic wave increases with increase in frequency. If frequency of ultrasonic wave is less, less is the speed. More is the frequency of ultrasonic wave, more is the speed. It means the speed of propagation of ultrasonic wave is directly proportional to its frequency. They show negligible diffraction due to their smaller wavelength. Since ultrasonic waves are having high frequency, naturally they are having small wavelength, and due to this small wavelength, they show negligible diffraction. And hence they can transmitted over a long distance without any appreciable loss of energy. Suppose ultrasonic wave has started its journey from position A and it reaches to a far distance point B. So whatever ultrasonic wave has started from A, it will reach to B, means there is no loss of energy in it. Intense ultrasonic radiations has a disruptive effect in liquids, causing bubbles to be formed. Suppose ultrasonic waves passes through the liquid, then it will causes bubbles to be formed, and this effect is called as disruptive effect. There are various applications of ultrasonic waves in industry, in medical field, as well as in scientific field. Let us see the applications. We know that ultrasonic waves are highly energetic and show a little diffraction, and hence they can be used for finding the depth of sea. Ultrasonic waves can be used to determine the depth of sea. How? Let us see. The time interval between sending the wave and reflected wave from the sea is recorded. As the velocity of ultrasonic wave is known, hence the depth of the sea can be estimated using the formula depth of sea is equal to velocity into time divided by 2. In this way, ultrasonic waves are used to determine the depth of sea. Sonar. Detection of submarines, iceberg and other objects in the ocean. It is possible to determine the presence of submarines or an enemy aircraft by a system known as sonar. What is sonar? Sound navigation and ranging. Sonar is a device which stands for sound navigation and ranging. In this system, a sharp ultrasonic beam is directed in various directions into the sea. These are picked up on their return after reflections. The reflections of wave from any direction shows the presence of some reflecting body in the sea. In this way, sonar works. Let us enjoy the video which will give us application of ultrasonic wave. Let us play the video.
Sonar. Sonar stands for sound navigation and ranging. It is a device which uses ultrasonic waves to measure the distance, direction, and speed of underwater objects and helps mariners to investigate the nature, size, and location of the object so that potential threat to the vessel is identified and overcome. How does it work? Sonar has a transmitter and a receiver which are installed at the bottom of the ship. The ultrasonic waves transmitted by transmitter travel underwater and get reflected back from obstacles. The detector receives the signal and converts it to electric signal. A computer forms image of the obstacle and displays it on a monitor. It also calculates distance of the object using this formula. Distance is equal to speed into time.
Ultrasonic waves can be used to find defect or flaws in the metal. This method is also called as NDT, non-destructive testing method, which is very much important application in industry. Ultrasonic waves can be used to find flaws in metal. When ultrasonic waves pass through a metal having some hole or crack inside it, an appreciable reflection occurs. The reflection also takes place at the back surface of the metal. The reflected pulses are picked up by the receiver and suitably amplified. In this way, we get the exact location of some fault, crack or defect inside the metal. Since it is three-dimensional objects in the industry, it is used. Inside that object somewhere may be some crack or defects, and it can be you find out using this ultrasonic wave. In industry,
non-destructive testing, ultrasonic examination
is the most important method
The
to
basic
find out
principle of
defect or
ultrasonic
flaws
testing of
inside the
materials
metal.
is the propagation and reflection of sound waves. As an example, a cylindrical workpiece is shown in the animation. The longitudinal section through the cylinder shows the position of the atoms extremely magnified and simplified as a single crystal. To begin with, a rigid unyielding stop is attached to the right front end of the cylinder. At the left front end, a disc is installed. It will be used to transmit and receive sound waves. Pushing and pulling briefly at the disc causes a longitudinal sound wave to propagate through the cylinder. When the sound wave reaches the rigid stop at the right side, it is reflected and runs back towards the disc, which now serves as a receiver. A free end is also able to reflect a wave. In this case, however, the tensile side runs ahead in the reflected wave and finally deflects the receiver to the right. The reflected wave is even reflected again and actually travels for several times across the length of the cylinder, but this is not shown in the animation for the sake of simplicity. So, if a sound wave is generated at one end of a workpiece, it will travel through the material with its speed of sound. At the free end of the workpiece, the sound wave is reflected and it returns to the transmitter, which then acts as a receiver. For ultrasonic testing of a workpiece, not a large transmitter is used in most cases, but a rather compact one, which generates a short ultrasonic pulse. At a place free from defects, the ultrasonic pulse travels to the right front end, also termed back wall. The pulse is reflected and recorded again as an echo. When the transmitter is moved a little downwards, the cavity reflects a part of the wave. That part arrives earlier at the transmitter than the rest of the sound wave. Even further downwards, the cavity reflects the complete ultrasonic pulse. For material testing, either the echo of a defect can be utilized, this is the pulse echo mode, or the phenomenon that hardly any sound waves pass through the imperfection. This is called the through transmission mode. In pulse echo mode, a transducer installed in a probe performs both the sending and the receiving of the ultrasonic pulse. On a computer monitor, the intensity is being plotted upwards on the y-axis and the time towards the right on the x-axis. With the probe at a place free from defects, only two signals may be seen on the monitor: the transmission pulse and the echo resulting from the lower surface of the workpiece, termed back wall echo. Moving the probe towards the right leads to an additional echo created by the defect. Even further towards the right, only the defect echo is visible apart from the transmission pulse. In our laboratory, there's a green painted steel cylinder to be found. It contains artificial defects which are invisible from the outside. To track down the defects, the material tester uses the pulse echo method. This is how a typical probe looks.
Ultrasonic waves are also used for cleaning and clearing. The ultrasonic waves can be used for cleaning utensils, washing clothes, and removing dust. This ultrasonic cleaning is generally used in hospitals as well as research laboratories. This ultrasonic cleaning also used to remove soot from chimneys. Some more industrial applications of ultrasonic wave. Soldering and metal cutting. Ultrasonic waves can be used for drilling and cutting processes in metals. These waves can be used for soldering. In industries, ultrasonic waves are used for metal cutting, metal soldering, and metal drilling. Ultrasonic waves are also used for mixing. A colloidal solution or emulsion of two non-miscible liquids can be formed by simultaneously subjecting to ultrasonic radiations. Nowadays, most of the emulsions like polishes, paints, food products, and pharmaceutical preparations are prepared by using this ultrasonic mixing. Ultrasonic waves are also used for crystallization. The crystallization rate is also affected by ultrasonics, and therefore it becomes fast. So ultrasonic waves are used for crystallization. The size of crystals when molten metal is put to crystallization can be made smaller and more uniform by the use of these ultrasonic waves. Ultrasonic waves are also used to destruct lower life. Remember, do not destruct, do not harm, do not kill lower life using this ultrasonic wave, but still it is one of the applications. The animals like rats, frogs, fishes can be killed or injured by using high intensity ultrasonic waves. These are some important industrial applications of ultrasonic waves. This image shows that how industry applies basic principles of physics and works smoothly. Ultrasonic waves are having various applications in medical field. Echocardiography. In this process, the ultrasonic waves are used to form an image of the earth using reflection of ultrasonic wave and detection of these waves from various parts. Most familiar application of ultrasonic wave is ultrasonography. Medical ultrasound is a diagnosis imaging technique based on it. It is used for imaging of internal body structures such as muscle, joints, internal organs. Ultrasonic images are also known as sonograms. In this process, pulses of ultrasound are sent to the tissues using a probe. The sound echoes of the tissue, where different tissues reflect the sound varying in degrees, and these echoes are recorded and displayed an image, which gives us exact identification of medical problems. Lithotripsy. Ultrasonic waves are used to break kidney stone. Okay, kidney stones are in the body and these are break into smaller stones and which can be removed out of the body. This lithotripsy technique is very efficient technique, and our Aurangabad all hospitals are having this technique which uses ultrasonic waves to break the kidney stone. Echolocation. Echolocation is the process where sound waves and echoes are used to determine object in the space. Bats uses this and he exactly get his food using this process. The nature of echoes help them to determine the size, shape and distance of the object. These are various applications of ultrasonic wave. There are tremendous applications of ultrasonic waves in various fields. We have discussed few of them. We have discussed what do you mean by ultrasonic wave, its frequency range, various properties of ultrasonic waves, and various applications of ultrasonic waves in different sectors. Now, let us see how these ultrasonic waves are produced. Production of ultrasonic waves. There are two important methods of production of ultrasonic wave. The first method is production of ultrasonic wave by magnetostriction method, and the second one is production of ultrasonic wave by piezoelectric method. Please solve this assignment which is in the form of Google form. Thank you.